We're at this really fascinating, kind of critical moment with artificial intelligence. As it gets more and more powerful, the big question isn't just what it can do anymore, but whether we can actually genuinely trust it. So today, we're going to dig into how we build that trust. And look, this is not some abstract, futuristic problem. Right now, AI is making decisions that affect our health, our safety, our finances. When the stakes are that high, trust isn't just some nice-to-have feature. It's everything. It's the whole foundation.
So let's start by really framing this central challenge. Because on one hand, AI promises to do some absolutely incredible things, but that promise is balanced by some pretty significant risks.
I mean, think about it. AI can help save lives, it can boost economies, but on the flip side, a failure can expose our most private data, it can reinforce terrible biases, or it could even cause real physical harm. The framework we use to navigate this tension is what we call responsible AI, and we're going to explore what that actually looks like in practice through 3 real-world case studies.
First up, we're heading into the hospital, a place where that line between life-saving innovation and personal privacy is just razor thin.
So here's the situation. A group of hospitals, they wanted to use their combined patient data to build an AI that could predict which patients were most likely to be readmitted. I mean, what a fantastic goal, right? The problem? They're dealing with incredibly strict privacy laws like GDPR, which meant they couldn't just throw all their sensitive patient records into one big central database. So their first solution was this brilliant piece of tech called federated learning. Here's the key idea. Instead of moving the data, they moved the model. So each hospital trained the AI on its own private data, right there on site. Then only the anonymous mathematical learnings, these little model updates, were sent to a central server to be combined. The raw patient data, it never ever left the hospital.
But they didn't stop there. They added a second, super strong layer of protection: differential privacy. You can think of this technique as adding a tiny, carefully calculated amount of mathematical noise or static to those model updates. And that noise makes it statistically impossible for anyone to reverse engineer the information to figure out anything about any single patient. It's a powerful mathematical guarantee of privacy.
And the result of all this? Well, it wasn't just safer, it was actually better. This collaborative privacy-first model was 14% more accurate at predicting readmissions than any model a single hospital could have built on its own. It's this perfect illustration that you don't have to sacrifice performance for privacy. You can have both.
Okay, so that case shows how we can protect data. But what happens when the stakes shift from our private information to our physical safety? Our next story takes us right inside the world of self-driving cars.
So I want you to picture this. You have a cutting-edge autonomous vehicle, literally one of the most advanced AI systems on the road today. It's driving down a normal suburban street, and it comes up on a perfectly ordinary stop sign. Its computer vision system has seen millions of these things. No big deal. But on this particular stop sign, there are a few small, harmless-looking stickers. A bit of graffiti, maybe a band logo. To a human driver, they're completely meaningless. But to the AI, they're about to be catastrophic.
So what do you think the car does? Does it stop? Does it just slow down and get confused?
No, it does the exact opposite of what it should. The AI completely misreads the stop sign. It thinks it's a speed limit sign and gets ready to accelerate. And what's truly terrifying is that the system was incredibly confident in its totally wrong decision.
This is a classic, textbook example of an adversarial attack. It's where someone deliberately manipulates an AI's input, in this case with just a few stickers, specifically to cause a complete and dangerous failure.
Okay, so what's most important here is how the company, Drive AI, responded. This wasn't just some quick software patch. They built a whole 3-part system of resilience. First, they launched a red team whose entire job was to constantly try to break their own AI. Then, they started something called adversarial training, where they deliberately trained the AI on thousands of these tricky manipulated images. And critically, they brought in independent experts for public oversight and annual audit.
And the results of this whole multi-layered approach? A reduction in the failure rate for manipulated stop signs by over 90%. It just proves that building truly robust AI requires a whole culture of constant testing and external accountability, not just writing better code.
All right, for our final case study, we're moving from safety to fairness, and we're going to look at a challenge that is every bit as complex: automated loan approvals. So a bank wanted to use AI to speed up its decisions on small business loans, but they knew that historical financial data can be jam-packed with hidden, systemic biases that could unfairly deny loans to minority-owned businesses or those in less affluent neighborhoods.
So the question is, how do you make sure your fancy new AI isn't just automating old discrimination?
To solve this, they had to turn to these amazing explainability tools, which basically help us peek inside the AI's black box. Now, as you can see here, they had a couple of options. Tools like LIME are really fast, but their explanations are only local, meaning they can sometimes be a bit misleading about the model's overall behavior. So they chose a more intensive but more consistent tool called SHAP, and SHAP revealed something critical. The model was heavily penalizing applicants just based on their zip code, essentially using geography as a proxy for risk, which disproportionately hurt businesses in certain communities.
This massive discovery led them to create something I think is absolutely brilliant, a model card. The best way to think about it is like a nutrition label for an AI system. This card transparently documents everything you see here, the model's intended use, its performance across different demographic groups, all the fairness checks that were run, and its known limitations. It's just a fantastic tool for transparency and accountability.
Okay, so let's tie all of this together. We've seen how to protect privacy in a hospital, how to build resilience in a self-driving car, and how to audit for fairness in a bank. So what's the common thread here? Ultimately, what these stories really show us is that trustworthy AI isn't about some single magic tool. It's a complete system. It combines the privacy-preserving technology from the hospital with the culture of adversarial testing from the self-driving car and the fairness audits and transparency from the bank. It takes technology, process, and people all working together. And that leaves us with one final thought. The methods and the tools we've talked about today, federated learning, adversarial training, model cards, they all exist right now. We know how to build more responsible AI, so the challenge is no longer just a technical one. The real question is for all of us. As employees, as consumers, as citizens, are we demanding this level of safety, fairness, and transparency from the systems that are so quietly shaping our world?